actually a pleasure to be here and kind of surprised and happy. I have been pursuing model-based systems engineering since I was working on a master's in systems engineering with Navy postgraduate school, and have been very happy to be a practitioner in mission engineering and analysis for the last 6 years since I transitioned into mission engineering, into our mission engineering and analysis department at the Naval Undersea Warfare Center. Today, what we're going to do is we're going to talk about some lessons learned that we have in merging the JCIDS process with elements of UAF, and just kind of some suggestions for how we have some suggestions that, or some lessons learned that we have on how to get stakeholders involved in the process. As Aurelius and Laura indicated, the modeling language is a tool. The modeling language is here to support a business process and making sure that you take that into consideration as you're developing models and as you're developing especially verification and validation paths for models, right? Who gets to have the final say on different elements in a model is extremely important. All right, the three main takeaways that you're going to get from today. The first is just because UAF has several hundred pages of documentation, several hundred model elements, does not mean that every modeling project that you do has to use each and every one of those elements, right? We're going to use the JCIDS process, the DoD acquisition process, to show how different parts in the JCIDS process end up giving imprimatur, or giving authority to different parts of the UAF meta model. The second is going to be I'm not going to say a case study because I don't actually talk about the program that we used it for, but it'll be lessons learned on how the process that is behind the development of the model is possibly more important than the actual data in the model at any point in time. And then the last takeaway is drilling down even further and understanding that understanding the operational effects of changes in the resource domain often require changing resource methods, right? So there's a relationship between, there's a nonlinear relationship between the operational domain and the resource domain that you have to address through other analysis tools. And then the stuff at the bottom actually is just kind of there because different stakeholders in the process are moving at the same time, exchanging information. What looks like a static, what looks like the ability to build towards a static model in the domain meta model is not. All right, so a little segue. The Office of the Secretary of Defense has published a wonderful mission engineering guide, and I highly suggest even non-DoD folks take a look at it, because what it does is it goes ahead and it talks about missions. It talks about the fact that a mission is the allocation of resources to achieve a desired effect in a competitive environment with constraints. And then it looks at mission engineering as a deliberate planning, analyzing, organizing, integrating of current and emerging operational and system capabilities to achieve, and I'm just going to say, desired effects, right? Since it's an OSD document, it talks about warfighting. But back from back from my days coming off of active duty when I thought I wanted to be an MBA instead of an engineer. This is the way business analysts think, right? So what are the opportunities? What is the competition? What is the environment? How do you characterize both your company's capabilities and other companies' capabilities? And then why do we do mission engineering? There's a bunch of stuff there in the diagram at the bottom. So inform concept development, inform technology implementation, inform acquisition requirements. What do we actually go out and buy? And then manage a capability portfolio is one of the more important things. All right, so early stage acquisition. This is the JCIDS process. This is the congressionally mandated way for the DoD to get an acquisition underway. Up at the top, it starts with what's known as a capabilities-based assessment, right? And so this looks at what the organization is doing currently, what tools they're doing it with, what is a threat environment, what is a projected threat environment, competition environment, and how well are we able to do it? How well are we able to execute in the future? From this, we end up developing capability gaps, and then if capability gaps are developed, we generate a document called an initial capabilities document, which documents what the tasks that can't be done with current capabilities or based on evolving threats are, and what the metrics associated with those tasks are, right? So a subset. If the ICD stage, the DoD acquisition process is supposed to be solution agnostic. And so even if we did look at, say, submarine warfare, anti-submarine warfare, and found that there were gaps in anti-submarine warfare, the solution, the ICD would quantify those gaps and would not necessarily specify that Department of Defense needs to go out and buy a new submarine, right? The next step in the process is the requirements validation, right? And what this does is it takes the capability gaps from the ICD and it goes ahead and maps those. First, it does a whole bunch of analysis to validate that those gaps are good, to quantify it, and to start to evaluate the initial solution space for those capability gaps, right? So in this case, you know, it might be looking at a new aircraft. It might be looking at reallocation of assets from one combatant commander from one business unit to another, or it might be, you know, adding sensors or whatever. During this requirements validation, you end up performing an analysis of alternatives. And so at some point, there need to be good enough conceptual designs on what those alternatives would be. There needs to be agreement of, or there needs to be a scenario mapped to the capability gaps, and then a formal analysis of alternatives needs to be done. The analysis of alternatives can use whatever the modeling, simulation, software that community uses. But one of the things that we'll end up showing is how storing the capability or how using UAF to map the capabilities, measures of effectiveness associated with those capabilities, to map the resource solutions associated with those capabilities, gives you the ability to manage your data, to map the inputs and outputs from different analysis tools, to make sure that you're using a common scenario, even if you are using different groups with different tools to do the analysis of the effect of a solution on a capability gap. And then ultimately, the goal of this is a capability definition document, right? And the capability definition document is the piece of paper that says, hey, we recommend that the Department of Defense go out and procure a new system. All right. And so back to the domain meta model, we can map the JCIDS process onto the UAF domain meta model. And so if we look at it, capabilities-based assessment goes ahead, describes the capabilities gaps in terms of capabilities and measures of effectiveness, right? What do we want to do it? What targets do we need to achieve in the future that we can't achieve with the current solution? The initial capabilities document goes ahead and puts an operational context around the capability gaps, right, in a solution agnostic term, right? And so again, if you look here, it's what what operational actor is responsible for achieving a given goal, right? So going back to the definition we had of capability, it is an effect in an operational environment with a given solution. But you can specify the effect, you can specify the quantity of the effect, you can specify the threat without talking about the solution. And then the CDD goes ahead and goes through the process of evaluating, well, the analysis of alternatives goes through the process of analyzing multiple resource domain or service domain or whatever solutions against the operational requirements. And then the CDD finally spits out the go by this document for the solution that comes out of the AOA. And so back to the first point, just because a model element exists doesn't mean that it has to be captured authoritatively at every spot in the life cycle, right? As we've gone through the JCIDS process, we start by getting a good handle. We start by getting an authorized or a set of capability requirements that are vetted, validated. We then move on to the ICD. We get operational need that is quantified, verified, validated. We evaluate multiple potential solutions, right? So the resource domain or services domain or whatever ends up having multiple engineering efforts applied to it to get candidate solutions that are then identified in the operational context. And then finally, you come out with the winner of the analysis of alternatives and the capabilities description document that you then evaluate into an acquired design. All right. It's asking me about an annotation request. No. Decline I. All right. Cool. Okay, so back to the wonderful OSD Mission Engineering Guide. We end up with two things, and actually I'm going to move down here, and I apologize just because I want to. I got to read something off the slide to make sure I don't misspeak. Okay, so up in the upper left-hand corner, we go ahead and we talk about the different levels of detail that go into specification of a mission when we're doing mission engineering. And so first there are the mission areas, right? And these are kind of the large-scale business areas for the organization that you're using, right? So again, the ones that are near and dear to my heart working at the Undersea Warfare Center are anti-surface warfare, anti-submarine warfare, strike, and then a few others. And these are just kind of general mission tasks that we can do, right? And this gets back to the capability requirements, the measures of effectiveness, right? For anti-submarine warfare, my measure of effectiveness is, do I find enemy submarines that are operating in a given area? And then if it's wartime, do I sink enemy submarines that are operating in a given water space area? Then we get progressively more detailed as we go into analyses, right? So where, when, what's the threat, how does the threat operate, what capabilities are we looking at for our own assets, and then how do we intend to employ our own assets, right? And then over on the top right side, this is just another view that kind of describes the, again, progressive specification as we move through. And then down in the bottom right-hand corner, this is a stereotype that we've been using for capturing mission areas and all of the different information requirements that are needed to run a mission analysis. And so as we move from the capabilities-based analysis where capability gaps have been identified and quantified, the first step in getting to the analysis of alternatives is to define the missions and to set initial objective values for what we think can be achieved through a given acquisition. All right. Okay, so this is where we get into the conceptual design process, and this is where things get a little bit interesting. So 3 layers to this process flow, right? At the top process is what in the Department of Defense we refer to as a resource sponsor, right? So this would be business planning, strategic thinking, so on and so forth. In the middle level, this is where we have the operations analysis. So the analysis community, the folks who have forecasting tools, modeling and simulation tools, so on and so forth. And then on the bottom level, we have the solution providers, right? So the solution providers are program offices, vendors, so on and so forth, right? And so if you think back a couple of slides, we talked about the ICD as being the capability gaps that are missing. And there's a set of architecture products that go through there. For the most part, they are operational activities, measures of effectiveness associated with those operational activities. For each operational activity, a mission scenario gets mapped to it, and there are needs that the operational actor needs to do that. And so this goes ahead and it tees up the need for doing a mission effectiveness study to evaluate potential solutions in the scenario against the gaps, right? It also starts up an effort in the platform layer, right, with the platform providers and designers for understanding what design concepts are. And so based on the mission scenario, we come up with mission effectiveness study, which goes ahead and identifies a simulation tool to be used, identifies the characteristics of a platform that need to be fed into that simulation tool, both for threats and for the platform under design. And that's the communication between the system designers and the modelers, the operations modelers. In the mission engineering thread model, One of the important things to consider, though, is that different solutions are potentially going to be employed in different ways. So if we're looking at a business scenario, right, if we wanted to produce a widget, there's both a retail mode of distribution and a direct consumer mode of distribution, right? Both of those sell a widget to a customer. Both of those are going to have different tactics with the solution required, right? For back to my bailiwick, if we do have a gap in anti-submarine warfare, right, I can potentially fill that by flying a maritime patrol aircraft. I can potentially fly that by flying a helicopter, because helicopter pilots are awesome. Or I can potentially fill that gap by flying a submarine. We're still evaluating the same operational activities in the mission evaluation model, but we're going to have to make different assumptions about the tactics that different solutions use in order to work, or in order to make the modeling work. But we need to make sure the modeling comes back up to the same mission measures of effectiveness, traced back to potential platform characteristics. All right. Yeah, and then we get to the analysis of alternatives on the other side. All right, so in this case, the model development process is as important, possibly more important than the model itself, right? You need to understand who your stakeholders are, what parts of the model they're going to be involved in, and how they go. Since I just got the 5 minutes sign, I'm going to go ahead and skip this slide. But I am going to stop here, right, and talk about this. This is a conceptual model for how we have been approaching a set of analytic studies leading up to an analysis of alternatives. And so you can see up here in the analytic study, these are multiple studies based on different groups. But then we have the resource sponsor authorizing the mission models, saying what the threat parameters, what the tasks that need to be evaluated are. And then we have solution providers, platform models, coming up with candidate architectures to achieve the solution. This is just a little bit more of a drill down. We're maintaining a database, actually in UAF, of all of the studies that have been done, of the measures of effectiveness that they've achieved, measures of effectiveness that are measured in each study, and what platform parameters are being used for that architecture, and then driving out of that. And so, I guess I didn't hit the last point I wanted to make as hard as I wanted to, but it really is the iterative process as you go through conceptual design, studies to evaluate the conceptual design, and then using the UAF framework, not necessarily to show direct relationships between resource characteristics and achieved mission outcomes, but being able to use the study as its own object to link the two and to facilitate statistical analysis of multiple heterogeneous solutions and studies. And so I'm going to go ahead and pause here and field questions. And I'm actually kind of happy because I don't see any closed eyes, so I didn't put anybody to sleep. Yes, sir.
So a vignette is not a UAF element type, and a mission effectiveness thread is not a UAF element type. There's very good ways to do it, but there's not necessarily consistent ways to do it across people who work with the JCIDS process. And I'm wondering if you think there would be a benefit in sort of establishing which UAF elements correspond to different parts of the JCIDS analysis.
So I am going to speak for myself here rather than I think the community. I don't think that there is a requirement to get overly detailed in specifying what UAF elements are used to document a mission thread, so on, et cetera. And the reason I say that is much like UAF kind of decouples mission effectiveness, or kind of deceptively couples mission effectiveness, right? Measures of effectiveness and resource measures of performance, because you can't just draw one straight line and say, hey, I need this measure of performance in order to calculate this measure of effectiveness. And it looks linear, but it's not always linear. I think that the scales involved in the different things that can get defined down into a mission thread vary greatly. And so that's to say I would love to get into a much more detailed conversation about that, and I think we need to, but I, especially at this point, very much push back against overspecification.
All right, thank you. There are a few questions online.
Yes. How do you model different mission vignettes which belongs to an overall mission scenario?
So each mission vignette ends up just kind of being its own instance, right? And so it ends up with geographic locate. It's specified by a combination of geographic location, threat, and other conditions, right? The actual operational activities for a given thread, should be the same if you're doing, strike from one location versus strike from another location. And I don't think that's actually in conflict. It's consistency inside a program or an analytic group, I think, is important. Consistency across the Department of Defense is, yeah, so, sorry.
In the chat, any efforts to establish reusable measurement set library?
So the reusable measurement set library, there's a couple of really good efforts in the Department of the Navy. One of the things that we do have is there is a standard library that it's the NAVWAR integrated dictionary. I think it's now the NAVAIR integrated dictionary, but it is a standard library. It does include the NTAs. It does include the naval tactical activities. It does include the tasks that make up the NMEDALs and Navy Mission Essential Task Lists. And it does include measures associated with each of those. One of the difficulties of that, though, is that all of those lists, right, the JCAs, the NTAs, whatever, primarily started as bog sats, right? So a bunch of guys sitting around a table just writing down good ideas, and while they are great from a standardization point, they are not a engineered product. And so could we do better with that? Possibly. Yeah.
One more, we can take one more question.
Trying to be the long pole in the tent when you're doing the conceptual design process.
So so honestly, the longest pole in the tent is that the designers want to bear down to a single solution that optimizes for all of the capability gaps. But all of the in a lot of cases, it's impossible to optimize for all of the capability gaps, right? because, you know, so like take a notional aircraft, right? We might want to say that a notional aircraft should be able to haul, you know, just tons and tons and tons of stores, right? But we also might want to say that the notional aircraft should have a relatively small signature and should be affordable, right? And so it, you know, Gary Fisher, bicycle designer, right, said, you know, light, cheap, or strong, pick two. And that, I think, is you know, one of the things that ends up happening, right? There's the iterative process that goes between the capability owners and the designers, where you're inevitably going to run into trades that can't be optimized, or trades that if you do optimize them, right, like I can, again, back to light, cheap, and fast, right? I can kind of go middle of the road for all of them, but that's not going to make any of the stakeholders happy. So,
All right, perfect.
really,
Thank you.
thank you. Thank you all.
Oh.